afternoon, everyone, and thank you for joining this, our first National Centre for Computing Education, the NCCE Digital Skills Forum briefing, bringing together tech experts from education and industry to look at how to deliver computing skills and opportunities for our post-COVID future, with a very specific focus on artificial intelligence and the future of education, an area which I am very passionate about. In a minute, I will share information with you about the NCCE. But first, let me introduce myself. I am Beverly Clark and I am the chair of this session. I work for BCS, the Charter Institute for IT, as the National Community Manager for Computing at School, which is a teacher-facing arm of BCS. We support teachers and educators from early years through to A-level through a network of volunteers, which is known as the CAS Community of Practice. We also work with academia and industry. I'm also an author of a published book aimed at supporting new entrants into the teaching profession, and I'm the writer of 2 AI curriculums with international coverage. Now, for a little bit about the NCCE. The NCCE is funded by the Department for Education with the aim of achieving a world-leading computing education for every child in England. It supports teachers at every stage from primary to A-level to improve computing skills and subject knowledge, providing resources, training courses, and working through its network of 34 school-based computing hubs. The NCCE is run by a consortium made up of STEM Learning, the Raspberry Pi Foundation, and BCS, the Charter Institute for IT. Since its launch in 2018, 10,000 teachers have enrolled on its Computer Science Accelerator program to upscale teaching computing to GCSE level. This has been a massive achievement. During this session, you will hear from 4 speakers, each with their own take on artificial intelligence and the future of education. Each panelist will speak for 5 minutes, after which I will then sum up and introduce the next panelist. Once you've heard from all of our speakers, I will then take audience questions that have been placed via the question window. So as you hear from each panelist, if you have any questions, please put them into the question window, where Julia and Vicky will be keeping an eye on the window. Before we start, a few housekeeping items. This session is being recorded. Cameras for panelists will be on throughout the session. Please can audience members keep their cameras turned off and microphones muted. If you are on social media, please do tweet and share insights from this session. The hashtag for this session is #DigitalSkillsForum. Julia is also putting these details into the question window. Now to introduce our first speaker. He is Professor Simon Peyton-Jones. Simon is a computer science researcher at Microsoft Research and has been deeply involved in computing education since 2007. He is chair of the NCCE, the National Centre for Computing Education. Additionally, he is chair and co-founder of Computing at School. Simon will set the scene for us about thinking in AI in detail. AI is currently everywhere and is doing a lot of good, but what about the flip side of that? Are we preparing our young people with an understanding of the critical strengths and weaknesses of AI systems? What dialogue do we need between education and employers? Simon, I'm going to hand over to you to develop on this, please.
Great, thank you, Beverly. I think our strapline is, how can education prepare the next generation for a world where understanding AI will be increasingly important? So that strapline conceals an opportunity and a challenge. The opportunity is, I want our children to leave school, and indeed as young adults, to grow up as young adults with a sense of agency and power, right? So that they're not the slaves of computer systems that are in control of them. They are its masters. I want them to be active agents in the world, able to make well-informed judgments about all this digital stuff that surrounds them so intimately. The challenge is that it all seems like magic, right? Arthur C. Clarke famously remarked, any sufficiently advanced technology is indistinguishable from magic. And so there is a danger that young people and adults will come to see computers, perhaps especially AI, as a form of magic. That is something created by people far away over whom we have no control. And if we utter the appropriate incantation, the computer may do the right thing for us. But if we don't utter the right incantation, it won't. And if we want a new spell, well, we have to go somewhere else and ask somebody else to do it. That's not power, right? That's just incanting things. So I think it's very dangerous if we come to think of our computer systems as magical. And I think that danger is extra strong in AI, right? AI really does seem magical, right? Self-driving cars, recognizing cats, designing circuits, and somehow in some mysterious and ill-specified way, all learned. Somehow the computer has learned to do this, quotes, by itself. That seems, rather than being taught to do it by people, that seems super, super magic. So our business, I think, or the business of education, is to let light in on the magic. So how do we do that? Well, what I think we should not do is tear up the national curriculum and reorganize it around AI and machine learning, right? So I think all of this artificial intelligence stuff is built on a foundation of understanding about how essentially how computer science work. How do computers actually work? Computer science is the study of computation, information, and communication. And children need some kind of foundational understanding of computing and computer science, just as they need a foundational understanding of natural science. And everything else is built on top of that, right? So it's not, we don't need to start again with AI. We just need to, as it were, we just need to teach our existing national curriculum well. I think there probably is some scope for a little bit of a shift of emphasis, though. So when I said computer science is the study of computation, information, and communication, I think we instinctively tend to focus most on computation. We speak about computers executing algorithms step by step. We talk about algorithms and do this and then do that, right? We don't think so much about information and data, which is clearly becoming much more important in this world of AI, or the communicational aspects of computers. So I think the whole AI revolution is giving quite a welcome boost to the information and data side of computer science. And I think it also stretches our thinking, right? So AI gives a qualitatively different way of getting a computer to do something that you want it to do. Instead of saying, do this and then do that, we say, here is a lot of data, please generalize patterns from it. So that's a completely different way of going about it. That's good mind-stretching stuff that I'd like children to get some sense of. Right? And I'd also like them to get to a sense of the strengths and weaknesses of those approaches, right? It's very difficult to write a step-by-step program to recognize a cat. Actually, it's not that hard these days to write a machine learning program that can recognize a cat. But if you just treat machine learning as kind of magic pixie dust, and you don't know nothing about data bias or overfitting or explainability or spoofing, you are very liable to build or deploy machine learning in a way that's just inappropriate or does the wrong thing. And I don't want that to happen. So I think some element of understanding about how these things work is really important. And that's what I want to see coming out of our education system. Perhaps a little bit of a shift of focus, but fundamentally, the national curriculum that we have in place now, let's just do it well. And even that is a major challenge.
Thank you
Thanks.
very much, Simon. Thank you. I really liked what you said there about let the light shine and the magic of AI and data. Data is very, very important, and an understanding of how data is driving the AI revolution, I think, is very important for our young people to understand. And I will remind our listeners, if you have any questions, please do pop them into the question window as we go along. I will now introduce our second speaker, who is Heather Peikoff, who is the CEO of Apps for Good. Apps for Good is a global charity preparing young people to thrive in a changing world. The charity has reached more than 220,000 young people globally and is dedicated to giving young people of every background the best life chances. In 2018, Apps for Good launched a machine learning course, which is now delivered to thousands of students globally. Heather, over to you, please.
Great, thank you very much. Yes, so nice to be here to speak to everybody. I did want to cover then today about our machine learning course. We've now had thousands of students taking this course, and I wanted to share with you today our top 7 learnings from these students and their teachers. So 1, don't start with the tech. Start with what tech can do and how it can be applied to solve problems, how it is creative and collaborative. So we've learned that sometimes starting in what feels like a code-free zone is more welcoming and safe for some students. And this is especially critical for girls and other young people who don't see tech as for me, initially at least. Two, it's important to keep it relevant to students' lives and to get under the hood of the technologies, showing how artificial intelligence is being used right now and how is it impacting their everyday lives. So one of the things we do is we get students to recreate Instagram's anti-bullying filter so that they can understand how it works, something they've probably come across in their daily lives. And so it's really making that connection to their lives and seeing how things work. Three, and as Simon touched on this a lot, the ethics side, that discussion really interests students. They want to talk about issues of equality and fairness, the use of their data, echo chambers, facial recognition, on and on. We've really seen that having considered debates around these issues motivates students of all backgrounds. Four, start early and ensure it's accessible. So for us, our machine learning course starts at year 9. So what we've done is really aim to have this sort of sweet spot between an entirely tech-free, unplugged approach on one end to something involving the most advanced maths and statistics on the other end of the spectrum. So we want students to know how AI impacts their lives, how it works, and then how it can be applied to solve problems. 5, bring industry into the classroom. So we partnered with experts to build our course, but then we bring these volunteers right into the classroom where they give students feedback on their projects. We have volunteers from companies such as Lego, Spotify, BNY Mellon, SAP, Salesforce, a host of companies globally helping these young people. This has been an incredibly useful scaffolding for teachers as it fills in gaps in their knowledge, as well as it helps motivate students when things get tough, as they eventually do. It shows young people how what they're working on connects to a real job, to real work that's happening right now. And it boosts the young people's confidence because someone from industry is taking them and their idea seriously. 6, support teachers. So we've seen that our teachers are really excited about this and they want to upskill themselves. So, one example is during the pandemic, we were sort of like, probably no, we're not going to get a lot of uptake of this. It's new, it might be seen as too challenging, but actually we've had teachers even start this during the lockdown as home learning because they felt it was something creative and relevant for their students to work on. And 7, young people's creativity is endless. So we get young people working together in teams, developing a real product using an iterative approach. So they learn to build fast, get feedback from users. They go from problem to prototype to pitch, just like in the business world. So they're building all those skills that are also needed within this context of automation. So teamwork, communication, design, research. They're developing their confidence and resilience, learning that failure is part of the problem-solving process. Students must come up with their own idea for the product. It can't be provided by us or their teacher. This is really challenging and more challenging than we found that our other technology streams. But what we've seen is, of course, AI can be applied to much bigger, large scale problems, certainly, but that it has been really useful for the young people to work on a project that's relevant for them and means something to them. So this motivates their learning because they're working on a project that they really care about. And we've seen some really creative ideas come out of this. So products use machine learning to make revision easier, to improve dental health, to reuse everyday objects out of rubbish, and another one to make ultrasounds more efficient and accessible. So these are 7 of the key things we've learned, in particular to engage a truly diverse group of young people with machine learning. And yeah, we're working with hundreds of schools right now, and we'd love to hear from you if you'd like to get involved. Thank you.
Thank you so much, Heather. That's really insightful. And I really enjoyed hearing about the collaborations you've made with industry. That's really important. And also hearing about problem to prototype to pitch and going through that life cycle and getting our students to understand that that is a cycle that they need to understand and go through, and understanding that it's just not starting with the tech, but what tech can do for them, actually harnessing technology. That is really, really important, because I feel that once our young people relate tech to each of their lives, that's when they understand the power of it and they start to take it a lot more seriously. And it isn't just something out there for other people or more clever people or any of the stereotypes that we tend to hear within technology. So thank you very much for that. And I will remind our listeners also, please keep putting comments into the question window. Okay, so our third speaker is Dr. John Chippendale. John is a primary school teacher as well as a visiting academic at the University of Manchester, where he champions engineering and runs the Computing Primary PGCE. John will be sharing with us insight into how primary schools are preparing pupils for the future workforce, and he will showcase emerging tools to introduce AI in primary and the challenges of delivering a curriculum which keeps pace with tech developments. John, it sounds like you've got your work cut out there.
That's quite
Over
a lot.
to you.
Right, I'm just going to share my screen as well because I've got a couple of slides here. Hopefully you can see that okay.
We can, yes, thank you.
Super. Thanks for the introduction, Beverly. Yeah, so my name is John Chippendale. I am a teacher and a CAS Community Outreach Manager, spending my weeks in the space of computing education. And I want to just talk through, in the short time that I've got, some tools that primary schools are already starting to use to introduce this stuff in the classroom, and then talk a little bit about the challenges in getting a greater number of teachers to do exactly that so we can get this out to all pupils. But first of all, and this kind of links to Simon's point, in fact, I've got 2 points in my presentation, Simon, that are going to link directly back to yours. It's almost like it's planned. First one is that we both have the Arthur C. Clarke quote in here. In the national curriculum, whilst it's not in the subject content at the beginning, it talks about this need to ensure pupils are digitally literate at a level suitable for the future workplace. So there is a kind of emphasis on us to try and keep up a little bit here. And as that future workforce and the technology used within it changes, we should be looking at how we can adapt things so that we can continue to expose pupils at an introductory level to the technology which is driving innovation. And also within the aims, it does talk about people should be able to evaluate new or unfamiliar technologies. So on the point from Arthur C. Clarke, we want our pupils to be saying, rubbish, it's not magic that the iPhone can separate all of the photos in it into the different people, my different friends. That's probably AI or machine learning. I might not know exactly the details of how it does it, but I've got an idea of how it does it. So that's the curriculum. But in terms of what some teachers in some schools and applications that they're starting to use to introduce this stuff, I've taken a couple of slides here from a resource that we put together in CAS called a CAS in the box around AI. And we kind of separated things out into those applications which enable pupils to interact with AI machine learning and interact with applications, and notice that it's probably able to do things which are slightly different to other applications that they've used in the past. So there's a nice selection here from Google, including things like Quick Draw, which can guess what you're drawing. And then we moved them on to actually doing a bit of creation with AI and machine learning. And there's a great tool by Dale Lane that interfaces Scratch with IBM's Watson so that pupils can create and train their own AI model. Great to see that another cat's making an appearance there. I'll tell you why in a second. Well, I'll tell you why now, actually. So the other link I've got on here is Teachable Machine. And whereas machine learning for kids takes a little bit of setting up, Teachable Machine doesn't so much. So it's really quick to do. And what I did just before we started, hopefully you can still see my screen here. Teachable Machine allows you to create a few different classes and then train a model to recognize images. So this one is called, is it my daughter or my cat? Because my phone is full of pictures of either my daughter or my cat. Perhaps I should have had a third class of my wife on there as well, but we'll just go with daughter and cat for the moment. And you can upload these pictures, then you can train your model, and you can start to talk to pupils about the technology at an appropriate level that's going on behind that. And there we go. It will output, then it uses the web camera. At the moment, I don't know if you can see under here, it's thinking that I am my daughter. That's because I probably look more like my daughter than I do my cat. And my daughter is at nursery, but he's been patiently waiting for this point. Here we have my cat, and you'll see then, you should be able to see that it goes on to very confident that is a cat. So there we go. So that's just another tool that some schools, some teachers in some schools are using to introduce this stuff. However, it's not about necessarily just some pupils in some schools getting access to this, we should be trying to broaden this as much as possible. So in terms of challenges in doing that, it's about developing teacher confidence, as other speakers this afternoon have talked about, supporting teachers to enhance their tech subject knowledge and also their awareness of the application of AI in the world around them. The point on encouraging more girls into tech, there's research on that which shows that they like to see the point and the application, and that they can have an impact beyond just the tasks that they are doing. So this is all about, at the end of the day, investment in teacher CPD to develop them as being more confident in this stuff. And also, just on the point, and kind of going back to Simon here as well, just looking at the curriculum, I understand the point about it all comes back to the basics, but also unpicking a little bit about, if we are going to have a progression in learning around AI, what does that perhaps look like? What do I teach first, next, and then after that? So there we are. I think I've just about snuck that in my 5 minutes there. So I'll come back to you, Beverly.
Thank you very much, John. That was most excellent. I was really getting into the image recognition there with the cat, and I nearly forgot to keep an eye on the time. So that was really good. And I particularly like the reference to the national curriculum and getting our students to be digitally literate. We do hear this quite a lot in the press, and I know certainly every time I look at Twitter, there's a reference to being digitally literate, and that is really, really important. I don't think we can emphasize that enough, because that is the key to understanding what is going on around us, to ensure that no one is left behind. And because we've got a digital divide, we've got a data divide, we don't want to end up with a digital literacy divide, because these are real issues that can occur if we don't take this seriously. And I do like the nice link back to Simon's point that this isn't magic pixie dust. This is, we do need to understand what's happening. It isn't something, that we don't have aliens landing or robots taking over. This is about us understanding. We don't need to understand every single thing at the finest details, but that understanding. And the Freddie meter, because I had the privilege or the pleasure of coming to one of your sessions and having a go on the Freddie meter and discovering how awful I sing.
Yeah, sorry, I did mention that one. That's you can sing into it and it will tell you how closely your tune and octave range matches that of Freddie Mercury's. That's a Google experiment.
Yeah, I'm miles away, so I'll stick to the day job. Okay, thank you so much. So our fourth and final speaker is Dr. Zoe Webster. Zoe is the Artificial Intelligence Director of Data and AI Solutions within the BT Group. Zoe has been interested in AI since reading her dad's Isaac Asimov books as a child and coding random stuff in BASIC. She took a Bachelor's of Engineering in Computer Science and an MSc in Intelligent Systems before heading to industry, where she applied cutting-edge machine learning techniques to a range of problems and completed a PhD in AI. These are excellent achievements. Zoe joined BT in November 2020 as AI Director, and she is also a non-executive director of the Data Lab and a school governor. Zoe, welcome, and over to you.
Thank you, Beverly. So when I think of AI in the future of education, I come at this as someone who studied AI from at degree level, but who's engaged with computing quite early. I also come at this as a parent of 2 young children and a school governor. The themes I'd like to talk about are governance and accountability, skills training, and diversity. So governance and accountability. So whenever AI is applied to recognise patterns or support decision making, and whether that's in education, the workplace, healthcare, the criminal justice system, wherever, accountability with humans is vital. AI is not magic. I didn't coordinate with Simon and John on this. It's a message I've said before, but AI is not magic. Like any computer program, it's a matter of following a set of steps as specified by a human programmer. So even if that AI is learning how to code, it's doing that by following a series of steps provided to it. If the human doing the programming is biased in some way, then the AI most probably will be too. In education, we need to be clear that it's a tool for people to use, but we shouldn't abdicate responsibility or accountability to it. Positioning this as vital, as is ensuring we arm people with the tools they need to understand the role AI can have and its limitations. My boss presented a vision of having an AI as a board member in a business, a bit of a thought experiment. That sounds intriguing, that if an AI can offer value, perhaps through spotting trends in data that other human board members can't see, or by retrieving information about competitors that might guide the board towards a particular decision. We can translate that into the education governance, and I'm a governor, so that's of interest to me personally, where AI could help spot trends in provision or performance data and make recommendations to other governors. The AI should not be accountable for decisions it informs. That should remain with the whole governing board and be positioned as a tool rather than a governor in its own right. So that's one of the factors I thought about in terms of AI in education. The next one is around skills training. So we are going to see AI being used more and more in industry for both back-end functions such as HR and legal, where AI can help with information retrieval, and customer-facing products and services, where AI can help to personalize offers to customers. This will have an impact on the tasks that people will be expected to do in future. So, for example, training in the legal profession has often involved trainees performing information retrieval to show that they can assess information and its relevance. When AI is used more and more to perform that function, how do we then train the next generation of legal professionals? The same might be said for healthcare professionals if AI is used more and more to detect and diagnose conditions. It isn't that AI outperforms human experts in these cases, but AI can point experts to the more complex cases that AI hasn't been trained on yet. And it's often when you combine human expertise with AI that the highest performance is achieved. We therefore need to think about the kinds of tasks that human and artificial intelligence are better suited for, or which tasks engage human intelligence and endeavour more and guide education accordingly. AI has another connection with education, and that's in its role in helping to personalise education based on the needs, preferences and context of a learner, whether that learner is at school, college, university or in the workplace. I think there's a lot of potential here, especially when combined with other technologies such as augmented and virtual reality. And my third main point was around diversity. We do need more diversity in terms of protected characteristics in the AI workforce to ensure that AI performs well for a wide variety of users and applications and is trusted. Education has a massive role to play here, but I'm guessing, based on my historic school and university experience, but happy to stand corrected, that AI education has the same kind of problem with diversity. Role models are important here. I had one, or rather two. I may not have gone down the computer science route and into AI and industry had I not been spotted by two female A-level computing teachers, including the head of department, as a student looking to change an A-level and given the hard sell. Actually, it wasn't that hard to sell, but it hadn't occurred to me before that to take it up at that stage and do it, take it on at that point. So we need more role models who can actively find students with latent interest. And that latent interest might not be on the technical or the STEM side, picking up very much on what was said earlier by Heather. The other part of AI diversity comes from diversity of thought and the role that many other disciplines have to play in successful AI development and adoption. These include the social sciences, economics, psychology, anthropology, law, and many others. In AI education, a broad view should be taken where possible to bring to bear all relevant disciplines, and through that, a more diverse and collaborative workforce.
Thank you very much, Zoe. Thank you. That was really, really powerful. Combining AI and education. I really like what you've introduced there to this conversation around diversity in AI. It's not just about gender diversity, it's diversity of thought. Also issues around bias within data sets. And I think this is one of the biggest ones that we see in the news, where there is no responsibility taken for the humans that are planning those algorithms and programming and coding and designing those systems. It isn't just something that's happening somewhere else. This is humans being translated into the systems. So that links very nicely to the trust in AI systems. And there is a very, very big space there where we need to get the public to trust AI systems, and I'm fairly certain that's laid out in the government's AI roadmap around trust in AI systems, and role models, very, very important for our young people to look to the future and see people that they could aspire to be within AI. And I also like your links with industry and giving us examples of how AI is changing different industries, like the legal profession, like healthcare. You know, we've got AI being used in image recognition within healthcare, and that's really, really important for our young people to understand what's happening, and not just our young people, all of us, to understand the impacts that it's making upon us. And the one that I haven't seen in practice as yet, but it's around AI being a board member. So moving away from being just humans sitting around that board table to having an AI. And that's, you know, that's a big, big concept. So hopefully in our discussion, we can develop upon that a bit later, but really, really enjoyed that. So thank you to all of our panelists for those insights. So, you know, we've set the scene from Simon. We've looked at the curriculum that Heather's company has created. We've seen what John is doing in school, and we've, you know, Zoe has introduced the whole concepts around bias and data sets. So I'll come to Julia now to see if we have any questions from our audience.
Hi, Beverly.
Hi.
Yes, hi. Thank you so much to all of the panel. So we've got a couple of questions that have come in. So is there any difference with introducing AI to different age groups? What do we need to consider? Could we ask the panel that, please?
Okay, so I think we'll come to John first on that, and then perhaps then go to Heather. So John?
Yeah, okay, so from a sort of teaching for progression perspective, I think that, and this kind of goes to the point that I talked about as a need really to sort of understand what a progression in understanding might look like, and not necessarily have that just around the tech side of things, but given there's been so many good points made by everyone on, you know, the potential pitfalls with biases or etc., or its application to things like deepfakes and fake news and all the rest of it, actually to have a progression and a development and understanding in that as well. Yeah, so that's my starter on that. That's what I think we need. Okay, thank you. Heather, would you like to come in there?
Yeah, that's really interesting to think about. I mean, ours has been certainly a practical consideration for us of, you know, one on the kind of maths and statistics ability that's required. And we've, you know, been really trying to, as I said, hit that sweet spot of some of it, of course, does get more advanced. And so our students are able to do that. So I think the progression is a really lovely idea to help sort of address that. So we have sort of found a way to kind of sort of select things and how to simplify it in some ways, but that has been challenging. The other challenging too has been mixed ability classes where there might be a class that's different. And so that has been another certainly a challenge for our teachers with the machine learning materials.
Okay, thank you very much. And I just noticed we've introduced a few items of terminologies and keywords as we've been through. And John, you just used the word deep fake there. Could you just, for our listeners, just sort of expand on deep fakes and some of the issues that they create in society?
Yeah, so my understanding, and please others jump in here. So from what I've read and what I find interesting about this is it's the application of things like AI and machine learning to create content that might look genuine in certain senses, but it's generated artificially. So there's a great website called This Person Does Not Exist. If you Google that, and every time you load that page, it uses, and others might correct me on the correct terminology here, machine learning or some other AI tool to generate profiles of which look photorealistic, but those people do not exist. And then it's the use of those images or images being manipulated of other people, politicians, etc., in this very convincing manner that can then be used to spread mis and disinformation. Yeah, that's my understanding. Please feel other people to add to that or correct me.
Thank you very much, John. I think that was spot on. And I like the introduction there around disinformation. That's one of the afflictions of our current age. It's constant. I know that Simon earlier mentioned a few key terms such as overfitting and around training models. I don't know, Simon, if you'd like to sort of come back in and develop upon that area for us, please. I think, Simon, you're on mute.
That's the first time today.
Okay, I can hear you now.
Towards the end of the day. Yes. So this is part of what I mean about you need to understand enough about your AI system to make appropriate use of it. If you have a very large machine learning model, it may, with a modest amount of data, so maybe it's recognizing cats, you show it, your 30 or 40 cats, it may learn to recognize those cats very, very well, and it may just recognize exactly and only those cats. But what we wanted to do is to somehow generalize to sort of cattiness somehow. So to do that, it mustn't have too much capacity. If it has too little capacity, it fails to as well. So overfitting is when you've learnt you've fitted too precisely to the training data, and therefore are ineffective against new cats. Right, it's like a self-driving car that can only go to Sainsbury's. As soon as you do anything else, no dice. That's overfitting.
Okay. Thank you very much, Simon, for that explanation. I think that will go nicely over to something that Zoe was talking about around diversity in education. And we've spoken about overfitting and just matching those data sets too closely. Zoe, is there anything you can develop around what can we do to ensure that there is diversity in AI education?
I think it's a perennial question. I can't pretend to have any answers, but I think it comes down to role models, and whether that's in diversity of thought or protected characteristics, having, but it comes to, for example, diversity around the protected characteristic of sex, which is something I've come across, is actually having women, children seeing women actually do coding, and actually do some of this stuff rather than hear about it and not see it, and all they ever see is, men doing it, which is perfectly fine, but they need to see a diverse set of people actually doing this stuff, mm-hmm. and know that they can approach them and seek help from them. I also think there's a perception, it's quite a geeky perception around this area, not just in AI, but kind of computer science more generally, that I feel quite strong about, that, if you're not spending 24/7 coding in your bedroom, you're probably not that serious about it. And I think we probably need to combat that, because a lot of us are a lot of people are more rounded individuals who maybe have other pursuits. And I think there's something there that stops people going into it. There's also the gap, as we kind of going into industry, I think this is seen as such a fast moving, paced subject that if you take time out for whatever reason, for whatever caring responsibility or some other reason, you're never going to catch up, or it's going to be too hard to catch up. And actually the basic concepts around a lot of AI they've not really changed at all for decades, right? I mean, neural networks have been around, the increased compute power has led into kind of deep learning, etc. The essential concepts haven't changed a lot. The tools and platforms we might use, the amount of compute power we might have available has, but these things can be trained, right? And people can upskill in that fairly readily, I would say. So I think we can increase diversity if we make it easier for people to come in and to stay in.
Okay, thank you very much, Zoe. I'll go back to Julia now to hear some more further questions.
Thanks, Beverly. Actually, we've had two questions that I can merge together. So thanks, Karenza, and also Dave. They're both asking about how we can educate effectively about critical thinking to build trust and to encourage enough scrutiny, and how we can ensure that children are kind of understand the whole context when well-informed experts, like people like Elon Musk, for example, warn us that AI poses a danger to the future of humanity. So how can we ensure that we equip our young people with the right critical thinking to be able to handle this?
Thank you very much, Julia. I think perhaps we might come to Heather first on this, because you've developed the Apps for Good machine learning curriculum. So would you like to answer that, please, Heather? Have a go at it.
Yeah, that's right. It's some really big but great questions there. I'll start with the second one quickly around the anxiety side about AI. And I don't have a full answer to that, but I do think a little bit also about how it's here every day right now kind of takes it away from robots and the kind of scary, some otherworldly thing. And of course there are challenges around that people need to see around the ethics about that. But I think showing that it's part of every day, and that's actually when they're on Netflix, when they're on YouTube, when they're on most websites, they're seeing AI. So it's, I think helping that kind of makes it relevant to them and shows them that it's not this big kind of scary long-term thing. And I guess, yes, in terms of, I think a lot of, probably going back to some of the points, and I'll more quickly probably turn it over to Simon, but that sense of really understanding sort of that it's not that magic. I think there's clearly been a theme that the others have mentioned, but that almost in a sense getting them to do it as well helps them see, okay, I can question this because I start to understand how it's applied to problems, and while maybe I'm not, you know, and of course not every young person is going to know the advanced and in depth, but they can sort of break that down. I think that's really helpful for them to say, oh, I see, and you know, the panelists have articulated this very well. So I think that's really important.
Okay, thank you very much, Heather. I don't know if John, you'd like to come in there, because you've shared, you know, you've run your AI curriculums with some of your young people, and how has it been received by your young people?
Yeah, it's been received really well. One of the kind of pleasures in working with young children is being around their creative minds, and actually it's really cool to see how when you introduce concepts and ideas and they start to comprehend those, they kind of start spawning lots of ideas on how they might apply things. So in fact, one of the projects that we're currently involved with running in school with a group of our ambassadors is with our caretaker really doesn't like squirrels pinching the birds nuts, so we're developing an AI powered anti-squirrel bird feeder. That's a bit of a mouthful, but it's great in that we're doing that with primary level kit. So it's Scratch, it's Lego Redo motors. I'm working with them, and yeah, I don't know if it'll work or not, but it's the journey as much as the outcome when it comes to learning. So yeah.
Thank you very much. Thank you, John. Thanks for sharing that. Julie, I'll come back to you for any further questions.
Thanks, Beverly. I don't think we've had any more questions, actually.
Can I just add a follow-up to Coenza's question?
Oh, yes. Okay.
There's just there's a Coenza's question you quoted earlier. She said, educate effectively around critical thinking, both to build trust and to encourage enough scrutiny. And I really like the way she's put in that question the idea that that building trust and encouraging enough scrutiny might both be the outcomes of the same thing, right? So it's like, if you understand something about how something works, you both trust it more and you know when it's appropriate to use it. If I understand how my hammer works, then I trust it to bang in nails and I don't use it as a screwdriver. And that's because I understand about hammers. If all I can do is utter a spell and the nail bangs in, tomorrow, utter the same spell, maybe the nail won't work. But I understand enough about the hammer to know that it's going to work in some situations, and it's not going to work in others. And I can also reason about when it might not work. So if I'm thinking about recognizing defective items on a production line, I might say, well, it might actually fail. It might not recognize the defective thing and think about what to do. But I can question it, so long as it's just a black box. You can't question it. It just seems, well, it's miraculous. So I keep coming back to let light in on the magic. And I think the difference between zero light, just not understanding at all, and a little bit of light is a lot, right? The difference between 0 and 1 is tremendous. The difference between 1 and 2 is, well, it's double, but it's not as much as the difference between 0 and 1. So that first little bit that we want all children to have, super important, super important.
Thank you, Simon. Thank you for developing upon those points. Thank you. Julia, is there anything else? Because I do have one question that I could ask, but is there anything else?
No, go ahead, Beverly.
Okay, thank you. The changing classroom of the future, and this is to all of the panelists. We've got about a minute left to go, but what do you envisage, what changes do you see coming to our classrooms, especially around things like assessment, and maybe we'll have AI in the classroom, such as we have AI in the boardroom? Are there any sort of predictions for the future that you can see? If anyone would like to have a go at that. So Simon, okay.
I'll offer one. So I think there's a lot of hype about AI in education. I mean, AI tutors, AI as teachers, in effect, that I'm pretty skeptical of. But I think in carefully targeted areas, the equivalent of cat recognizers, we perhaps should do quite a lot. So to take note that I know something about programming, right? So maybe we could have an IDE, a development environment for programs in which that would sort of automate away some of the more routine things that teachers have to do. Put the semicolon here, and I advise you to do this. Stylistic guidance. There's lots of stuff that teachers do that is quite low level. Perhaps we could automate some of that away, free the teachers up to do the you're just structuring this loop completely wrong. You haven't got the idea. That could be quite helpful. So I could think that maybe I could see if fairly quickly for some, as it were, well characterized, relatively low level educational tasks to be automated away. I do not see the role of the teacher being automated away at all. I want to free teachers up to do what they're best at.
Thank you very much, Sam. And I think on that note that I will start bringing things to a close. So I would like to say, first of all, thank you to all of our speakers today. That's been really, really useful, helpful. I've learned a lot, and I certainly hope that our listeners have learned a lot also. And thank you very much to our listeners and our audience for joining us. And this has been a very forward-looking session. And we've really explored how the education system could adapt to the opportunities and challenges that AI presents. So if you'd like to find out more about what we as the NCCE are doing to support teachers and how you can be involved, please get in touch directly. And Julia is posting details into the question window. So please do get in touch. And also, this is part of a series. This is the first in a series of these monthly digital forums. So please do keep an eye out for our invite for our next event on the 8th of July, where we will be continuing the conversation around digital skills and post-COVID recovery. And then from September, we'll have a break in August, but from September, these, as I mentioned, will be run monthly. So once again, thank you everyone for joining us today, and have a lovely evening.